Now we're continuing talking about how to solve systems of linear inequalities. And now we're going to be working with just different types of graphs that you could see and equations that you could see. All right, so remember, when you solve a system of linear inequalities, you're really looking for coordinates or x and y values that work in both of the inequalities, kind of like what you do with systems of equations, but now you have inequalities, okay? So just like in all the other problems that we've done so far, you start by graphing both of these on the same graph, and then you look at their shaded parts and you look at where they overlap. So you've got to graph one at a time. So just like what we did with the problems before, we're going to take this first one, we're going to rewrite it, and we're going to act like we're graphing it like a normal equation, okay? So with this one, you could graph it the way it is. You remember, if it's in standard form, because that's kind of like in standard form, you could graph it by finding the x and y intercepts, which we will do in a little bit. Or you could take this one and rewrite it in slope-intercept form. So remember, slope-intercept form is your y equals mx plus b. And so that means you want to get the y by itself. So to do that for this one, I would have to subtract my x. So I'm going to take this one down here, and I'm going to solve for y. So I'd have to subtract my x to both sides. That way I can get the y by itself. So then x minus x is 0. My y comes down. That will stay the way it is because I did not multiply or divide by a negative. Remember, if you multiply or divide both sides by a negative number, you have to flip that sign, so don't forget that. And then I'm going to rewrite it in this form. So I want my x part first. So my negative x is going to go first, and then my minus 2 would go behind, okay? So I'm going to graph that one here in a minute, and I'm going to, just for the second that I'm start graphing it, I'm going to ignore the inequality just for the second. And so there's the one I'm going to graph there. Now, if you wanted to go ahead and get this one in slope-intercept form, you could do that. Or if you wanted to do it in a little bit, you can do that too. So I'm actually going to go ahead and graph this one. So when I graph this, remember, you start with a y-intercept, so it's going to hit the y-axis at -2. So put a dot there. And then the slope is technically a -1, so that would be like -1 over 1. Slope is rise over run. So that means you go from this point down 1 and right 1, -1 over 1. So down 1 and right 1. And so we're going to graph that. Just keep following that pattern. And then to go the other way, you do the opposite. So you go up 1 and left 1. And then once you get your points, you can either use a ruler or you can use just the edge of a sheet of paper if you need to. I'm going to see if I can find a ruler here. There we go. And you connect your dots. So don't forget to connect your dots. So let me see if I can connect these. And now, before I do this, make sure that you look at your inequality. So my inequality, it's going to be dotted if it doesn't have the equals to. It'll be solid if it does have the equals to. So this one's going to be dotted because it doesn't have the equals to sign underneath. So when I draw it, I'm going to go ahead and make sure that it's dotted. So my line might be a little off, but I think my ruler wasn't exactly lined up to begin with, but oh well. But hopefully you guys can get the picture. So remember, the reason why it's got to be dotted is to show that all the points that are on that line will actually not be part of the solution to this problem, because these points that are on the line will not actually work in that inequality. That's what that means, okay? Now go ahead and shade. So remember, that's where you find a point that's not on the line and you plug it in to test it out. So the point that I like to choose is 0, 0, because if it's not on the line, because it's just easy to work with. So if I plug in 0, 0 here, my x value would be 0, my y value would be 0, and I add them, and I'm going to see, does that work in that equation? If it does, that's the side I shade on. If it doesn't, then I shade the opposite side. So 0 plus 0 is 0. So I'm going to look at that. Is 0 greater than negative 2? Well, and 0 is bigger than negative 2, and so that means I have to shade on the same side that this point's on. So notice all of this area is the side I'm going to shade on. And remember, you want to shade kind of lightly because you're about to have to graph another line on that same graph. So when you shade, just make sure you kind of leave it a little bit lighter so that when you graph the other one, you don't get messed up. Okay, so there's that line. Make sure you shade the whole region. And then from there, we have to graph this other line on the exact same graph. So just like what I did for this one, I'm going to look at this one and solve it for y. So I have to take this and copy it down. Then I'm going to solve for y. So I'd have to add x to both sides. So add x. Negative x plus x is 0. My y comes down. And I did not multiply or divide by negative, so that's just going to stay the way it is. And then I'm going to rewrite it so that it's in this form. So my x comes up front, and then my plus 1 goes behind. Okay? And now we graph it. So imagine that this is an equal sign, and then we're going to graph this like it's y equals mx plus b. So start with the y-intercept, which is at 1. So I'm going to go my y-axis to 1. And remember, ignore your other line in the shading while you're doing this so you don't get messed up. And then I graph my slope. So the number that's in front of x here is like a 1. So that'd be like a 1 over 1. So that means I go up 1 and right 1. So just keep following that pattern. Go all the way to the edge of your graph. And then you go the other way, so you do the opposite. So down 1 and left 1. And then you can take your ruler or the edge of a sheet of paper and you can connect those to form your line. So let's see if I can get it a little bit lined up better now. And then before I draw my line, I'm going to look over here. It doesn't have the equals to underneath it. So that means I'm going to draw a dotted line because that means that all the points that are on this line are not part of the solution set to this equation. So I have to show that these are not included by drawing a dotted line. Okay, and then make sure you draw your arrows. And now we just have to shade. So again, make sure you ignore the other line and the shading while you're doing this, okay? And so when you're trying to shade, and I didn't mention this in the other one, so I'm going to mention it now. When you shade, you want to look at it when you have actually solved for y and you have your y on the left side of your inequality, okay? And so if you're trying to just kind of look at it and reason through it, you're really, like if you think about it, you're looking at where the y values are less than the line. And so if you think about it like that, you would think, okay, well, here's my line. Where are the y values that are less than it? And it would be below it, and so you would know you have to shade below that line. Or, like I said, you could pick a point, and as long as the point isn't on the line, you could test it out. So like if I picked a point 0, 0, it's not on that line, so I could plug it in just like I did the other one and see if it works out. If it works out in the equation, then I shade on the same side as the point. If it wasn't, then I shade on the opposite side of the point, okay? So I'll take my test point 0, 0 and plug it in. So it'd be negative 0. So negative 0 is just 0. Plus 0 is less than 1. And then that'd be 0. And is this true? Is 0 less than 1? Yes, it is. And so that means that this side, the same side that the point's on, is the one I shade. So this is actually on the right side of my line. So I'm going to shade the entire right side of this line. And make sure that you ignore the other one. So notice I'm shading everything on the right side of this line that I just graphed. Everything. The whole side of that, okay? Then, just like the other video, to find the solution to this system, you're looking for the x and y values that work in both of them. So that would actually be where their shaded parts overlap. So all of the coordinates that are in this region right here, And I mean, the graph could keep going. So all the coordinates that are on this side of both of those lines would work in both of those equations. So just go back and kind of shade it a little darker so that I can tell and you can tell when you look back at it where your solutions are. So any coordinate that you pick out here should actually work in both of these equations. So you could plug it in and check it if you wanted to. Okay, so let's do a couple more where you practice graphing and shading and finding the answers. Okay, so this next one. Both of them are in standard form, so you could graph them by finding the x and y intercepts and go at it that way. I prefer to solve for y, and so the first thing that I'm going to do for these is solve for y. So here I'd have to subtract my x, so the y would end up all by itself. I didn't really multiply or divide by a negative, so it'd still be less than. And then because I'm subtracting x, it would be a negative x on the other side and then plus 2. So there's that one. Then I'm going to graph it. So I come over here. My y-intercept is 2. So I go to 2 on my y-axis. And then I graph my slope. It's negative 1. So it'd be negative 1 over 1. So that means I go down 1 and right 1 to graph my line. So I'm going to graph this. Okay, and then to go the other way, you go up 1 and left 1. And then when I actually draw my line, I have to look. It doesn't have the equals to underneath it, so that means it would be a dotted line. So I'm actually just going to come through and make this dotted, since it's a pretty easy line to draw here. I say that and then I mess up. All right, and then I have to talk about shading. So before you move on to the next line, make sure you shade first, because if you try to shade both of them at the same time, most people usually confuse themselves, okay? So you choose a point to test out, or I could look at the equation as long as my y is on the left side. I'm looking for where the y values are less than that line, because this is like the equation, this is the graph of that right there. And we're looking at where the y values are less than that. So the y values, if I look at the y values in relation to this line, the y values that are smaller than that are actually down here, which means I'd shade this part. Or you can plug in that 0.00, just like I did in the other one, and test it out. Okay. Either way, you would find out that this side of the line is where my solutions are. Okay. Then graph the other one. So if I solved this one, I'd have to subtract my x again. And so when I do that, I get, and I'll just write it down here, those go away, y, my inequality doesn't change because I didn't multiply or divide by negative, negative x plus 5. Then we graph it. So my y-intercept is 5, so 1, 2, 3, 4, 5. And then from there, this actually has the same slope as my last one, so I go down 1 and right 1 to graph this one. And then whenever I actually graph it, I'm going to look, does my inequality have an equals to underneath it? If it does, it's going to be a solid line. If it doesn't, it's a dotted line. And so notice my inequality does not have an equals to, so when I draw this line, I'm going to dot it. So I'm actually going to go ahead and dot it, which means that all the points that are on this line is not going to work in that equation if I plug it in. So that's what the dotted line tells me. And then I shade. So in this one, I'm looking at where the y values are bigger than that line that I just graphed. So look at that line, ignore the other one. Where are the y values that are bigger than that line? Well, if I look at just my y-axis, here's kind of where the line is. Which numbers, which y values are bigger, and it would be on this side. And again, you could use the test point and plug it in and be able to know where to shade to. But either way, like if you plugged in 0, 0, it actually wouldn't work in that equation. So that means you have to shade on the other side. So either way you do it, you would find out you have to shade above this line or on this side of this line. Okay, and then just like before, to find the solution to these equations, you're looking for an x and a y value, a coordinate that works in both. And notice their shaded parts don't overlap, which means that all the solutions to this one equation will not work in the other equation because their shaded parts don't overlap. So this is one of those that is no solution, because if they don't have any coordinates in common, then there won't be a solution to that system of equations. Okay, so let's do a couple more, just so you have a couple more examples. So this one, they were very nice in this one because they actually already put it in slope-intercept form for you. So all you have to do is graph it. So this one, I'll start at 6 on the y-axis. So 1, 2, 3, 4, 5, 6. And then I graph my slope. My slope is -5 over a 1. So that means I go down 5 and right 1. So 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I think I'd run off the graph, and then I'm going to go the other way. 1, 2, 3, 4, 5, and then left 1, and then I'm out of graph. Okay, so from there, I look what kind of line I'm going to draw. This one actually has the equals to, so that means I draw a solid line, because that means that the coordinates that are actually on this line will work. So let me draw my line here. So just draw it solid, showing that all those coordinates that are on that line would work in that equation. Okay, then we shade. So you can choose your test point 0, 0 and plug it in here and to see, do I shade on the same side as the 0, 0 or the opposite side? Or since the y is already on the left side, you're looking at where the y values are less than or equal to that line. So in other words, you're looking at where it's kind of less than, because we've already covered the equal to part by drawing a solid line. So where are my y values below this line? Well, it would be these right here, which is kind of the left side of your equals. So you would shade on that side. And again, if this doesn't make a whole lot of sense, you could plug in that test point like we talked about the other day. Okay, so any of these coordinates here would work in this equation. Now we have to figure out of all these coordinates which would also work in that one. So we're going to graph that line. So I go to -1 on the y-axis. Then I have to graph, the slope is 2 over 1, so I go up 2 and right 1. And I keep following that pattern. So remember, you've got to ignore that other line while you're graphing so you don't get messed up. Then go the other way. And then you connect your line. So this one, it doesn't have the equals to, so this one would be a dotted line. So I'm just going to go back through and dot it, which means the coordinates that are on this line will actually not be a solution to that equation. Like if you plug in the x and y values from the coordinates that are on the line, it won't work in there. Okay, then we're shading, and you can choose, since 0, 0 is not on that line, you could use that and test out if it works or not. Or you could look, okay, if I look at this line, where are my y values bigger than that line? So if I look, my y values are actually kind of on this side of that line, above it, so that means I shade kind of the left side. So I'm going to go through, and I'm going to go at a different angle than I did the other shading, so I can see where they cross or overlap. So notice I'm ignoring my other line at the moment in the shading. I'm shading in the whole top of this line. Then I'm going to look at where they cross. So they actually cross everywhere in this region right here. So any of these coordinates, I'm going to go back in and I'm going to shade that in a little darker. Any of these coordinates in this region right here, kind of to the left of this line and then above that line, would work in both of those equations. So this one has a good area in the graph. Okay, so let's do one where you actually leave it in standard form and graph it that way, since we haven't done one like that, and then I'll let you guys work. So what if we had a problem like this and you just wanted to leave it in that form? Well, what you'd have to do is you'd have to come to the side and you would have to find the x and y intercepts first. So with this one, remember, to find the x-intercept, you plug in 0 for y, so that means that part goes away. Okay, so you'd have, like, for the x-intercept, you'd have 6x equals 12, essentially. And so the x divided by 6 would be 2, so your x-intercept is 2. And then to find the y-intercept, you need to plug in 0 for x, so that makes your x part go away, so you're left with 4y equals 12. So divide by 4. Y would be 3, so your y-intercept is 3. Excuse me. Oh, there went my lid. There we go. All right, so the y-intercept is 3, okay? So from there, you can graph your line, but then you'll have to remember to come back and shade. In these, you'll have to actually test out the point, because if you're not going to solve for y, you won't be able to do just kind of reasoning through it very well, okay? So this line hits the x-axis at 2, it hits the y-axis at 3, and then you can kind of find the pattern or the slope of that line by just looking at those 2 points. So the slope, I'd have to go down 3 and right 2. So I'm going to keep that pattern going to get a couple more points so I can get a good line graphed. Okay, then to go the other way, you do the opposite. So up 3 and left 2. And then go ahead and look at what kind of line it's going to be. It's got the equals 2, so that means that this is a solid line. So I'm going to draw my solid line. And then we just have to shade. So this one you have to actually plug in that test point. So I'm going to choose the point 0, 0, plug it in. So 0 times 6 would be 0. 0 times 4 is 0. I'm going to see, does that work? So is 0 greater than or equal to 12? And it is not. And so that means that that side will not work, so that means I shade the opposite side. So any point that's on this side of this equation, or of this line, excuse me, would work as a solution to this. Now I do the same thing for this one. So I'm going to go to the side, I'm going to write it down, and I'm going to find the x and y intercepts. So to find the x-intercept, remember you plug in 0 for y, which would just get rid of that part. So we're left with negative 3x equals 12. Divide by negative 3 on both sides. So your x-intercept, I'll just go ahead and write it down like this, ends up being negative 4. Then to find the y-intercept, you plug in 0 for the x part, so that makes that go away. You're left with 4y equals 12. Divide by 4. Y, so your y-intercept, in other words, would be 3. Now we know where that goes. So x-intercept's where it crosses the x-axis. So I go to negative 4, 1, 2, 3, 4. That's where it's going to cross the x-axis. Remember to ignore your other line while you do this. The y-intercept is 3, which actually happens to be that point right there. It's okay. Then just like you did before, find that pattern. So like to graph this line, I'd have to go to the right 4 and up 3. So I'm going to keep that pattern going. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 2, 3. And then to go the other way, you do the opposite. So 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. And now we look at what kind of line. It doesn't have the equals to, so it's going to be a dotted line. So here's my dotted line. Okay, and then we shade. So choose my test point. I can use 0, 0 again because it's not on my line, so plug it in. That would be 0 plus 4 times 0, 0. And then I'm going to ask myself, does this work in that equation or not? So is 0 greater than 12? And it is not. So that means I do not shade on the same side as the 0, 0. So that means I shade the other side of that line. I'm going to make my shaded area. I'm going to kind of plan ahead. I'm going to make it to where it goes a different way than the other shaded area I put so I can see where they overlap. And then these are the answers for the first equation. These are all the answers that would work in the second one. Where they overlap is the ones that would work in both of them. So all of these in this region would work in both of those equations. So any point in this region would be a solution to that system of equations.